So far in the session, what we have learned is we have learned to create the data frame, and we also learned to create the we also learned to interoperate between the data frame and RDD, meaning we can convert an RDD into data frame by two mechanisms, as well as we learned that we can create data frame from various kinds of data sources. All right. In continuation with our discussion on the data frame, we were about to discuss that we can create data frame from Hive as well. All right. What's the significance of being able to connect to the Hive? Most of the big data work as of today happens on Hive, specifically the work that involves structured data. So when the work is happening from Hive on structured data mostly, that means that in industry, most of the people's work, as in most of the tables and most of the stored procedures are created for Hive. Not stored procedures, but the views. Okay. Now, so what Spark guys did was they made it possible to query Hive via Spark for the tables. All right. They did not delegate entire query processing to Hive. They only used the metadata. They only used the metadata of Hive to access the details about various tables and various views. All right. And this is a very important step because this makes Spark capable of doing a lot of structured data processing. Okay, so let's take a look. So basically, if you are setting up your own installation, what you have to do is you have to copy hive-site.xml, core site XML, and HDFS site XML to the conf folder of Spark. We have already done it in case of the Spark of CloudxLab. So you do not need to do this. Okay. So what's the advantage of this? Why does Spark needs these three files? Spark using these three files would be able to access the Hive meta store as well as the other services like name node, data node, and so on. So basically, that's one of the reasons why these three files are quite useful for the Spark's configuration. All right. Now, in case you are building an application in which you need to connect to Hive, then while creating the Spark object, what you need to do is you need to enable Hive support. You need to enable Hive support. All right. So say you have a table called a_student inside the default database in Hive. So you can simply use this kind of syntax to talk to the Hive table. Let's take a look. Okay. There's a question from David that tomorrow is Mother's Day in US. Will there be a class tomorrow? Probably today will be the last class. Okay. Today will be the last class. We will learn about the Spark data frame as well as MLlib and GraphX. All right. And in case there is some overflow, we can do it some other time, and we can have tomorrow as holiday. Okay. All right. Another question is, when is the project overdue? When is the project overdue? Project is generally to be submitted after 15 days from the last session. Okay. Within 15 days from the last session. So that means 15 days from today is going to be around 30th May. Okay. So question from Alok is, can we use the lab afterwards? Yes, you can use the lab. You can renew your account in case you want to use it for more, as long as, right? So, okay. So, all right. So we have extended the lab to, I think, 30th May. Okay. And we'll have to take a look at why is this happening. So yeah, could you just drop this email to reach us at CloudxLab? My team would quickly review what happened and then try to fix it. Okay. All right. Okay. Okay. So yeah, Shravanti, you please also drop an email. We'll take a look. And you can definitely use the lab afterwards. Okay. You can just renew, extend manually, or refer a friend, and then that'll be it. Another question is, if I miss the deadline, can I submit it late and then earn the certificate late? So we generally prefer that our students submit the work within time. But if there is, if you are expecting certain delay because of some other commitments, so please let us know upfront. Okay, please let us know upfront so that we should be able to give you the certificate in case you are going to miss the deadline. All right. All right. So great, great. Now let me, I wanted to show you this part. So let me just launch. Okay. Another question is when we have project discussion. So project discussion we will have towards the end, as well as we can discuss it over the email, or if you want to have a one-on-one discussion, that also we can organize. Okay. All right. So let me log in into the CloudxLab. First, let me export the two variables. Sure, sure. I'll share the link for MLlib and GraphX. No worries. If you want it now, You can access these all slides are available in the LMS inside the slide section, and you can take a look at that. So those who, since Hitendra would be leaving earlier, so I'm just sharing it now. Okay. Okay, so great. Moving ahead, those who missed the slides for this one, I'm sharing these slides for Spark. Here you go. Okay, so great, let's move ahead. So this is our Spark 2.0.1. Now we just importing a Spark implicit. It's just a good habit to import these. Next is, so here we are saying select star from A underscore student. What does it mean? We are essentially talking to Hive. Hive has a table called A underscore student in the default database. Okay, in the default database. So let's say I'm logging in into another account. Okay, parallelly, just to show you that the Hive also has the same set of tables. Okay, so you can see df dot show. You can see, so this table contains these rows. All right, is the same table that we have here. Let it come up. So Spark can behave like a gateway to Hive as well. Okay. A question from Binta is that could you share the export variables? Yeah. So let me see. So this is the first command, and these are the other two commands. Okay. So let me just launch one of the nodes so that I can quickly copy it. All right. So you can see that we were able to talk to Hive. Now here I can show you select star from, what was the table name? A underscore student, where, and here I can say limit, say 20, so that it doesn't overflow my screen. A question from Grishma is that why am I seeing this error? Probably, did you launch using the same command as I have pasted here? Okay, so because you went to Scala, that's why there is no Spark object. All right, so now this will be useful for others. Now, this way we can actually execute any complex query on the tables stored inside Hive. Okay, so we don't need to worry about, bringing those tables here and so on. We can leave the tables there. Here, what's happening is Spark is going to Hive metastore. Hive metastore is the one that keeps the table information, table metadata. So Hive's metastore is being accessed by Spark, and then Based on the information it gathers from the metastore, Spark is doing its transformations and actions on top of the data that is underlying those tables of Hive. Okay, so essentially you get the best of both worlds. You get the power of Spark and you get the configurability of Hive, meaning you get the table structure from Hive. Okay, so you don't need to necessarily move the tables to Spark. You can directly use them. All right. So next is, all right. A very good question from Rajan is how much of SQL features can we use, for example, joins and select for updates and logs? So good question. So except for updates or insert into an existing table, couple of rows, those kind of things are not generally utilized or generally done using data frames. Because the way the model of data frames is that when you are, the data frame's objective is to be able to query any data, to be able to do the analytics on big data instead of being able to modify big data. Okay, in case you are trying to concurrently edit a table and so on, those kind of things should be better handled by NoSQL or any other data store. Okay, so but you can definitely do joins even between one table from Hive, other table from JDBC. Okay, that is the power of Spark. All right, now the next thing I want to show you is this interesting part where we are going to talk to MySQL, right? So first of all, what we're going to do is, first of all, we're going to access this particular driver. What is a driver or connector? What does driver do? Driver gives you the implementation of JDBC. This is a JDBC driver. So when we are connecting from a Java program or Scala program to any database, we need to provide the driver API to our Java program or Scala program. Okay. Now this driver basically gives you the implementation of how to talk to a particular data da- database or particular um, data store. Okay, so the connector is the gateway from Scala or Java into any database. Okay, so if you are connecting to Oracle, you will have Oracle connector. If you are connecting to MySQL, you will have MySQL connector. All right, so that's what is a driver. So we have kept a copy of MySQL connector for you. Okay, you can just take this copy to the local. Okay, you could just say, okay, in the second terminal, this is what I'm doing. Okay, I had already copied it, so it's already here. Now this is the file that basically contains the logic on how to connect to MySQL. It's a general connector, as in if you're writing your usual programs, then also you will use this. Let's say you are writing a web application in Java and you would like to connect that web application to MySQL. In that case also you will use the same connector. All right. Now, next thing is, now here we are saying Spark Shell. Here you can see, here we are saying Spark Shell followed by driver path, driver class path. So this is our driver class path. And then we are handing over jars. All right. So this makes this jar or the connector available to our logic. We can do the same thing with Spark Submit also. All right. Can somebody share the slides with Mohammed as well? Okay. So here we go. All right. So let me convert this into a single line. Okay, here we go. A question from Binta is that where slash how can I create find jar file of Hadoop FS this? Okay, so let's take a look at the command again. Okay, let's take a look at the command again. Here you can see what does command say? Command says Hadoop FS copy to local this particular file. So this is in HDFS. So this file we have already downloaded from MySQL driver. So you can generally find any driver, like you could say MySQL, Java, JDBC driver. Okay. So here you could download that particular driver. Okay, this is the driver that we have downloaded. So this way you can connect to any database. So the point I'm trying to make is that we can make our data frames or Spark SQL or Spark connect to any database if we have the driver of that database. The driver is generally provided by the provider and provider of the database. Okay, so you could generally, let's say JDBC driver we are trying to find. So you can download and use that. Okay, this is the one for connecting to my Microsoft SQL. Practically, every database on the planet provides a JDBC driver so that every Java application can talk to them. And here, in case of Scala, we can use the same database driver. Okay, now I'm going to terminate my other one. Here, uh, once we have connected to, once we have launched a Spark Shell, had we launched Spark, not Spark Shell, but Spark Summit, we will have to create a Spark object instead of using the out of the box one. Okay, now we are going to talk to MySQL, and the MySQL one is here. If we are going to connect to this particular IP address, where did we get this IP address? You can generally find it in either from the administrator in your cluster. In case of CloudxLab, it's available in the MyLab section of the page. Okay, there you can find the details about it. Now, once we are done with that, then we can, once we know the IP address of the MySQL, the database name, as well as which table you want to access, with what's your login name, what's the password, and so on. So we fill in all of this. So we say that spark.read.format JDBC, option URL is this, option database table, DB table is this, and the user is this. Okay, so based on your configuration, you can find out the values of this, and then we can create the data frame to a particular table. Okay, we can create the database Okay, let me just show you this part. Ah, this I need to convert that into let me just convert everything into a single line. Ah, okay, so let me just try again. All right. All right. So you can take a look at what has been loaded into this particular data frame. So you can see that it has loaded the table from MySQL. Okay. At the same time, you can actually connect to MySQL. MySQL this username is scoop user, and host is, I think, MySQL. Okay, so here you have -u for username. Okay, MySQL -u for username. Okay, what's the username? Username is scoop user, right? And then we have, all right, -d. Okay, now what else do I need to specify? I need to specify the host name, -h, -h, and there I could specify this IP address. All right, and then I'll say -p. Okay, that's it. And here in the after -p, I could specify the password. All right, so I'm just trying to connect to the database. Okay, in case you want to connect to the same database, you could try this. All right, so here we have show tables. Okay, and inside show tables we have the many tables. And which one are we loading here? Here we are loading widgets, right? So we could say select start from widgets. Okay, is it same as this one? Yes. Okay, so we have we've created this data frame from the MySQL. So we've created data frame from various kinds of sources, and good news is that we can join across these data frames and efficiently process the data from many sources and combine it and save the results to any source, any data store. A question from Vidya is, do I have to run it in the new console? You can, yeah, you have to run it on the bash or on the Linux shell. You can exit the current one and then launch this, or log into another terminal and launch this command. Okay, All right. So what we have learned is stepwise is that from all kinds of sources, whether SQL or you can say Hive, Parquet, JSON, normal RDD, or normal text file, and whether using all of these, we were able to create our data frame. Also, on the data frame, we were able to launch map as well as reduce. On this data frame, we were able to run our SQL queries. Okay, so and using SQL query, another data frame was created. So this is like dataframe.sql and then query. Here we are creating the data frame from our DBMS. Here we are creating the database from Hive, data frame from Hive, and then Parquet, even XML. XML we have not mentioned here, and so on. So you see that we could create the data frame from all kinds of sources, as well as, let's say we want to convert our data from Parquet into JSON. So all you need to do is load the data from Parquet and save it as JSON. So all kinds of permutations are possible because of a central common language or central common denominator called data frame. So the thumb rule is whatever structured data we have from any source, create the data frame, and then operate on the data frame, and whatever is the result, then you can save the data frame anywhere. Okay, if you have unstructured data and you know the structure, you know how to convert it, then you load the unstructured data into an RDD, either using text file or binary files. You can create RDD from any data, and then you can convert that RDD into data frame if you know how to convert each raw record of the RDD into a table. All right. So this is the thumb rule. A question from Rajan is, can I now run query against widgets? Now let's say, now like I say, df equals spark.sql select from widgets. Yes, you should be able to do. Okay, not like this, not like this. So you again have to basically load the entire table just like this. So you have to say, right, once you have created this data frame, right? So, not here. Okay, so we have this data frame, JDBC data frame. Let's now create parallelly the another data frame. What was that? This one. Okay, so let's try creating this. Okay. Um, all right. Let's say we have two data frames. One is JDBC-DF, okay, which has ID, which may have ID, let's just say. So yes, it has some marks. If you want to join marks with the ID of JDBC-DF, let's try. So we'll have to, in case, let's say we want to operate on these two tables, okay? So what we have to do is we have to spark dot okay, let me just show you what are the okay, just give me a second. And what is that we're trying to do? We are trying to we are trying to convert JDBC. We have how many data frame? One is this data frame, correct? other we have is this data frame. Okay, this one is coming from table. So we can always say create or replace temporary view. Okay, create or replace temporary view. And we are naming it what? What was the name of the table in case of our normal database? It's called widgets, JDBC widgets. This is the view that we are creating. Similarly, for the DF was another data frame. And DF represented what table? A student table, right? I'll just give it this name. Okay. Now, I could say Spark and I could say select star from JDBC widgets, comma, Hive students, and say show. You see, I was able to join the two data frames from different locations. Okay, so this came from JDBC, this came from Hive, and I'm able to log in that, or able to join that. Now let's say what I want to do is I want to filter out based on the marks. Okay, based on the marks equals ID. Okay, so I'm going to say where h.marks equals j.id. Okay, so this way it has done the job. All right, you want to take a look at my history. Okay, so this is something that you'll find useful. All right, let me just clean it up and share it with you. Okay. All right, let me explain again. So this is a very important step. So what we did. Okay, so if you take a look at whatever we're learning one step at a time, but you can combine all of that. Okay. All right, Binta, just give me a second. I'll explain this and we'll take a look at it. So first of all, what we did was, first of all, we created one data frame using the JDBC from our usual database. Then we created another data frame from Hive. This one is from Hive. The default set of tables that we have is from Hive. Next is we registered both of these data frames as the views in the Spark's view space. Afterwards, we are saying Spark.SQL, since these views have been registered, or these data frames have been registered as view, these are now available to Spark.SQL method. Okay. Now when I execute this, it is able to find it, and we are joining on these two tables. All right. So you can see that we were able to join the data from two disparate or two different sources. All right. I'm going to put it in the notes here. What did I do? Okay. All right. Let me just see if I could quickly paste it here. Okay. Joining across. All right. So yes, now I can take a look at Bintao's problem. All right. So great. A question from Bintao is that when I try, could I run this under Scalar directly? Not really, not really. You will have to run Spark Shell and on the command prompt. There you have to specify which file you are trying to load. Okay. All right. Bintao, you want me to take a look at your screen? Okay, go ahead. In the meantime, let me answer David's question. Since today is the last class, was the table created for Spark DataFrame versus Python versus SQL? Not yet, but if any of you are interested to help me out, it'll be great. It'll be great because that will also clear your understanding. And just let me know if any of you are interested to do that. I would love to explain to you in detail, and then you can do that. Okay, okay. This way it won't work. You will have to launch from the console itself. You have to exit from here and launch it again. Okay. You have say Control D and then.
Okay, Control D.
Yes.
Now I need to do it again from here.
Yes. The one which I copy pasted, that one I have converted into single line. That is easier. Okay.
But this one you here, I need to log to
You
scale.
convert it into a single line. Yeah. Copy paste and convert it into single line using Notepad.
Okay, notepad. I need to open one notepad. Where I found one? Notepad.
No, any Notepad.
Okay. Got a new one.
All right.
I need to go like this.
Yes. That's it. Put a space after jars.
This one?
No, after jars. Yeah. After jars. JARS. Between jars and MySQL. Can you see that? If you go a bit ahead, like 5 characters ahead from the cursor, then you will see.
Yeah, jar, which jar here?
Yeah.
Here, this one?
After, yeah, this next. No. Just next character. You made a space before that. Okay.
And
JARS space
I,
JARS
hold
space.
on, let me check here.
Okay.
Parse my circle jars.
Yeah. Dash jars is an option of Spark Shell. Okay. So
Yeah.
between the file name and the jars, there has to be an option. There
Yeah.
has to be space. Yes, that's correct. Now you can try.
Okay.
All right. So it should work.
Okay, I will try.
All right.
Where it is? Where is
No
my?
worries. I have shifted. No worries. Okay. Great. All right. I have muted also. Moving ahead and yes. So great. Now, the Spark data frame, the way we have described it is basically it is a distributed data frame, which means that it does not consume memory while we are operating on it. It consumes memory across multiple machines when we run the data frame. That is the difference between the data frame of Spark versus data frame from Pandas. Okay, that is the biggest difference between the two. Pandas data frame remains in the memory, and if the data that you're trying to load in Pandas is one library from Python. If the data is not loaded, is data is bigger than the memory, then you can't really load it in Pandas. All right, so great. So I think if anybody wants to help me out with creating a table of differences between Spark data frame or say Pandas, I would love to. I'd love to see that. Okay. A question from Raju is, if we don't want to use the driver option, then where the jars should be stored? Okay, good question. Good question. If you don't want this to be um, loaded that way, then so whenever you're creating your Spark application or anywhere, the way you want to hand over your jars is by the way of dash jars. And even if you put them in the libs, that may not work so well. So though you can actually put it in the libs also, okay, in the in the /lib folder or in the conf folder, uh, it should work, okay, but I'll have to take a look at that. Okay, so in one of the cases we have done that we have put the jars at central place from where it picks up. All right, so but in normal way, keep in mind that since any code or any program that you want to refer to, any library that you want to refer to from your Spark code, that code must be available on all the machines in the network. That means that you need to send it to all the machines by using --jars option of Spark shell. Okay, if that one is a jar file. Okay, so Spark SQL, right? So Spark SQL can behave like a distributed query engine. Okay, using its JDBC, ODBC, or command line, users can run SQL queries on Spark without the need to write any code. Okay, so now let's say that you have what you want to do is, let's say you have Hive server, and in the Hive server, what you want is that when people are uh, so let me go back again. So the way there was something called a Hive server, right? And in the Hive server, people could connect to it from their BI tool or from Tableau or from Excel, right? In the similar way, Spark also provides something called thrift server, which is basically a distributed way of processing data, and it provides you the interface to many the visualization tools like Tableau, Word, or Excel, and so on. Okay, so you can launch the start thrift server command from the console, but keep in mind that thrift server thrift server should be launched by the administrator, and because it binds itself to a port, and it makes the entire local store of the Spark available to the users. Therefore, the thrift server should be started by the system administrator. Okay, so so you can basically ask, if you are in an organization where what you want to do is you want to do big data analysis on the fly from the BI tool, then you can use this distributed SQL engine. Okay, and so your UI or your BI tool will hit the distributed SQL, and then distributed SQL will do the rest of the work. Okay, will do the rest of the work. Whatever SQL you want it to execute, it will execute those SQLs on Spark. Okay, so you can run this, and using a start thrift server, you can run it. The only thing is that you need to be sysadmin to do this, and then you can access it from the anywhere. So here I am trying to show you that if we start the thrift server, then we will be able to connect to it using a generic SQL console like Beeline. Using Beeline, we can connect to it very easily. Okay, and let me try to show you. This is something you may not be able to do it because you require root, which we don't have for the end users. Okay, so let me just exit from here. All right. So we are saying sudo, and here we are saying sbin, and then we are saying start thrift server. Okay, so I can't run it from my account. I'll instead log into my administrator account. Okay, so I'm logging into the administrator account. Okay, also before that I will have to do the proper exports. All right, here I go, and let me do sbin. Oh, again, I tried to log in using this, so I'll have to. This is something that you can't do because you are not administrator. And yeah, when you launch it, it basically creates a file here like this. It creates a file here. Okay. And yeah, that one is the one that is basically the one which is having the log. Tail -f. Okay, so it says that it is up and it's ready to accept the connections. Once we are done there, then we can launch the Beeline. Okay, then we can launch the Beeline. Beeline is very generic. Okay, very generic. Beeline is a generic. Beeline is a generic what do you say, generic client for any database. Okay, Beeline is a generic client for any database. Okay, so here bin Beeline, and there we could say connect to this port. Okay, this is where, all right. So right now we have just launched one dummy server, which is basically listening on 10,000 port. And when it's listening on 10,000 port, then we can connect to that one at 10,000 port from anywhere. Okay, whether right now it's just Beeline, it could have been something else, and so on. So basically, whatever data frame have you stored, whatever tables are there in Hive, all of that can be queried from anywhere by connecting to this Spark server. So this is basically Spark SQL server. This is basically the one that we launched using this command. Using this command, we essentially launched a Spark server to which we can connect from anywhere, whether it's your Excel sheet, whether it's your BI tool like BERT or Tableau, you can always access that one. And when you execute a query from Tableau, even on humongous data, it will be executed by Spark SQL on the cluster instead of overloading your machine. Okay, so that's the magic about this thrift server. So now we can say show tables and take a look at the tables. All right, so you can see all the tables from Hive and everywhere are available here. Okay, now you can query it, and when you query it, the work, the joins and everything will be done by Spark on top of the cluster. Okay, so that's the idea about, that is the idea about that's basically the idea about launching the Spark SQL server. Okay, all right, so I can stop the thrift server using the similar one script provided in Aspen. So I've just shut it down. Okay, so now it says that you can't connect. All right, so this is what I tried to demonstrate. The idea was that you can, if once you have launched your thrift server, then you can connect it from anywhere. So that was pretty much about data frames. All right, so any questions on the data frames? So again, going back to this one, you could do everything using data frame if your data is structured. So
We
generally,
pass RDD into data frame.
what?
We pass RDD into a data frame.
We pass RDD into data frame.
Yeah.
We convert an RDD into data frame.
Yeah.
So if we have unstructured data, that data we load it in the let's say we have unstructured data, we generally load that data into the RDD We load that into an RDD, unstructured data, and if possible, we convert the RDD into the data frame by using those two methods that we discussed last time.
Okay, I got it.
Okay.
Yeah.
So essentially, the process of converting an RDD into a data frame is called ETL. That could be using Python, that could be using Scala, that could be using any other language. All right. Uh, so should I move ahead to the next topic? All right. So Subbu's account is also not working. Subbu, and everyone whose account is not working, just please reach out to us at cloudxlab.com and we will extend it. Okay. Those who have missed on the classes in the between, they can do two things. Number one, they can watch the videos which are recorded in studio. They are small videos. Okay. The second is they can watch the recordings of the session. The third is that the one recommended method that I suggest to everyone, that for every session, just go through the slides, and if you have a confusion in the slides, just take a look at the video. Okay, that basically clears up everything.
And Sandeep, I have one question.
Yes, go ahead.
So, like tomorrow, today is our
This
last
is
class.
this is
Alok.
Alok, right? Okay.
Yeah, yeah. So, so like in my course, whatever I am seeing here, the content and the self-learning material.
Yes,
So those will be available means, or it
yes,
will also
yeah.
not be there.
No, they will be available to you.
So I can go through any time to the videos and the
Correct,
whatever the
correct,
content are there.
correct.
Okay, okay.
Okay.
Yeah, thanks.
Sandeep, today is our last class?
Yes.
Okay.
Okay. All right. So going ahead. So this was basically the data frame. And I would like to give you a brief introduction of machine learning. Okay. Let me just, okay, there are two questions that I would like to answer now. One is from David. Please go over the project again. Should we use Scala or for the project? So yes, I'll go over the project, don't worry. And second question is from Rajan. In the recording, is there a way to see the chat sessions? I'm not sure if there's a way to see the chat sessions, but I would like to request my team uh, to make it available, make the chat sessions also available in the class. Okay, upload the chats to the LMS, right?
So Sandeep, all the recording will be available in my course only, or some other place I can find out.
Uh, right. No, so I'll just show you. So wherever they're available right now, they'll be available.
Can you
Okay.
show us one time?
Yeah. Yeah. So for me, there are quite a few videos here and there. Therefore, it looks overcrowded. But for you, it'll be clear. So if you go here, my courses. In the my courses, you will see this part. This part is basically the one that you should generally follow. This is the short videos with all the exercises. Okay. Now that's the main course, and then there are recordings like here. You will see the here PDHS May 20 and not this one, not this one, this one. Say for example. Scala and Spark ILT. This will be visible for some, and Scala Spark. This will be visible for some, and this will be visible for some. Okay, so you could go into that, and you could take a look at that. All right. So this is the session from right. This is basically the recordings. This is the entire course that you could take a look at, and these are the recordings. Either this will be available to you, and you can actually go to next or previous. You could jump between these. Okay, so today is 14th session. Okay. All right.
So, Sandeep, these are the slides on only the slides.
No, not only slides. It has also the recordings, right?
Okay.
Okay, it has
We
everything.
can go to the last one for the slide, correct?
Yeah, so inside each of the topics, so basically there are two parts to the content. One is the self-paced course. This is the self-paced course. This course contains the self-paced content. This is a studio recorded version of these classes. While whatever has been done is kept in a separate, you can say, playlist, and that's whatever is the recording that is also kept here. Okay. So this way you can access it. All right. Okay.
Yeah.
All right. And the presentation slides will be available in all of these. Each of the topics have the presentation slides. Let's say if you want to take a look at the presentation slides in the Zookeeper, right? So you could click here, go to resources, and take a look at the slides here. So this one contains the slides. Okay. Similarly, for others also, other topics as well, you could find the slides in the back there. All right. So in the self-paced course, the self-paced course is the one that contains all of the content, and it has all the questions and everything. Okay. While the recordings have only recordings playlist has only the recordings. Okay. All right. So question from Bintao is, could you build real-time analytics dashboard as a Spark project? Yes, actually you can start if you are interested in doing that. Please start working on that. We will, in the meantime, we will make that available on the in the LMS. Okay. All right. Great. Great. Moving ahead. So great set of questions. Now, I'd like to give you a quick brief introduction to machine learning. So machine learning is about programming computers to optimize performance using example data or past experience. So this is the classic definition where computers giving the field of study that gives the computers the ability to learn without being explicitly programmed. But let's understand it by the way of an example. So how many of you have played Mario in past? Has anybody played Mario in past? Okay. Okay. Question to all of you is, have you win the princess so far? How many of you have win the princess? Do you think it can be automated? Just like you learned to play Mario by yourself, do you think it can be automated? All right. So that's what we're going to discuss. So the way I want to explain to you machine learning is in terms of this game. This is 100% real. It basically is not a concept. It is actually done. Okay. So, and in a similar example, we have taken in our machine learning class also that how do we do it? Okay. And we did this today itself. This is an example of reinforcement machine learning. So let me okay. So in Mario game is quite popular in which you move Mario from one end to another, collecting the coins, stamping the Goombas, and so on, right? Now, the way it was automated was that we run Mario inside a NES simulator instead of running on actual machine, and then let our program monitor the memory of the simulator and let it observe the game and observe the score based on the game state as well as the keys. So it keeps on pressing the keys, keeps on learning which one is giving it the best result, and that learn from it how to play the game. So let's take a look at it. So on the day 0, this looks like an infant. The Mario is jumping back and forth, and it is not going anywhere. And you can see the keys here. Keys are being pressed crazily, and it's not going anywhere. Okay, so that was day 0, like an infant. After a while, after a couple of days of learning, it's able to move ahead a bit. You can see it's able to move few frames in future, and it's badly stuck here. Few more weeks of learning again and again, making mistakes and improving upon those. The computer is learning by itself, and now it seems to have no problem at all. It seems to have no problem at all. You can see that. Okay, do you think it'll cross it? Yes. All right. So you can see that it's able to play actually better than myself. Few more weeks of training, it's able to play Mario really well. So you can see that it's about to exploit a couple of bugs. See that. What was that? What was that? Let me see it in slow motion. When the Goomba is jumping on it, it starts moving downwards, and then it basically fooled the game. The program actually fooled the game into thinking that it's not Goomba which jumped on it. Instead, Mario jumped on it. So now you can see another trick. Wow, I have no idea how did he do that. So the same one was played, same program tried to learn other programs, but in case of Tetris, it kept on pausing the game. In case of, because it could not win the game, so it kept on pausing the game because that was the only way to retain the score. So it kept on pausing the game, just like in childhood, our siblings would spoil the game when they were about to lose. So in the same way, when the program is about to lose, it will pause the game and will not move ahead. So that was an example of machine learning. That was an example of machine learning. Okay. So here, essentially what we saw was the program learned to play Mario and other games just like us. The question was, how can it learn? How can it learn by itself? Okay, so we basically coded the program such that it can press the keys observe the environment and tell that this is the place where the score is kept, or this is the place where the score is kept. So it will keep on hitting the keys. So it will keep on hitting the keys and tries to maximize the score in every possible way. Okay, that is the purpose of the game. All right. So that's basically it uses the neural networks in order to figure out the relationship between the environment, current state of environment, and the next steps. Okay. So the program learned to play Mario by itself and several other games without any need of programming. Okay. So to make this program learn any other game such as Pac-Man, we will have to, number one, write new rules as per the game, or just hook it to the new game and let it play for a while. Which one do you think is right? Yes? Just hook it to the new game, and since if the score, if it knows where the score is on the screen, it can play any game. All right. All right. So did it make sense to you, everyone? If you have any questions before moving ahead, please ask.
I have a question here.
Yeah.
But the concept is you have to make it play for a little bit so it learns from how it is to be played, right? Then it tries to optimize. If we just leave it for it to learn by itself, will it learn by itself?
It learned by itself only.
Because first you train it for a little bit and then it tries to optimize its performance.
Right. So basically, that's a part of algorithm that it plays a bit, optimizes a bit, plays a bit, optimizes a bit, and that's how it is going. Okay, but everything is automated, as in it is right now playing it and just pressing the keys and trying to observe what went wrong, what's going on, and so on. So it basically it plays and then learn, plays and then learn, and so on. Okay.
So
All right.
Sandeep, how it is doing? It is we create a model or we create a programming such kind of thing. It optimizes it, or we use optimized code. How it is doing?
Right, right. So basically what we do is we feed this as data to our algorithm, and there are standard algorithms to do the prediction. Okay. So we feed the whole screen as the data. The whole screen contains how many pixels in this case? It contains around 2000 pixels. And we feed the 2000 pixels as the data to our program along with the, and then ask the program that what should be the suggested keys. So in the beginning, the program suggests random keys, and then based on the past experience, it will start suggesting the right keys to press. Okay, so that's what happens. So on our machine learning program is the one which is looking at the screen, suggesting the keys to press. Then after pressing the keys, whatever is the result, it learns from that and then keeps on doing it. All right.
So we feed data into the models.
Data into the algorithms, and algorithms create the model mental map of what is giving the results and what is not giving the results. Okay. So this was a complex example of machine learning. Okay.
Sandeep, can you give recording permission to me?
Sure. Okay. Anybody else needs recording permission? I think all of you have already. So this was a very simple example, not very simple example, a very simple to understand example. Okay. So I'll give you like an example that you can correlate and that you can also find it possible to do it manually. Okay. So let's take another very simple example. Imagine that you know your salary. Okay, imagine that you know your salary of past. Okay, so here on this axis, you have what you're trying to do. Let's say you know your salary of past, and what you're trying to do is you want to predict your salary for the next year. Okay, that's also a machine learning task. Now, so let's say your years of experience is one axis, and you figure out that and the salary you have written as on another axis. Okay, so let's say for okay, now let's say for 1 year of experience your salary was this much. Okay, your salary was this much. For 2 years of experience, 2 years of experience, your salary was this much. And for 3 years, your salary was this much. And let's say for 4 years, your salary became little higher and then saturated and then saturated, right? Let's say this data you have. So, and you're trying to figure out what will be your salary in 2019. Okay, so what do you think my salary will be in 2019? How will you find out your next year's salary? First year, second year of experience, third year, fourth year, fifth year, sixth year, and so on, and next year. So let's say this is the information you have, and you have plotted it on this, right? So one is Alok's way of doing that. That is 30% hike. Okay, but sometimes that's not the case. Okay, sometimes that's not the case. So let's say in this case, we come up with multiple ideas. First idea is let's draw a straight line through the data points. Let's say like this. Okay. And right. So what we generally do in case of machine learning is we try all kinds of lines. We'll try this line, this line, this line, this line, and so on. There are just too many lines which we try. Okay, but in case of machine learning, since there are better algorithms available which help us figuring out that which line is suiting best, okay, and very quickly. So though the algorithms such as gradient descent help us quickly zero down upon the okay. So these because there are just too many lines, you could have this line or this line or this line or this line and every angle it. So there are just too many. So in these cases, what we do is we basically use optimizations such that we only try those lines which seems to give us benefit. Okay. And sometimes you realize that, okay, this straight line is not a great solution and we need a curve. We need like a round curve. Okay. We need a round curve. Let me just try to draw it. Let's say this is our parabola. So we might want to fit a parabola, or sometimes we may want to use the neural network in order to predict, because non-linear things can be predicted by them. Okay, so all we do is figure out the line that is trying to, here we are just trying to say, we are figuring out the line which is fitting through the data. We call this as linear regression. Now, there could be many more parameters. There could be another parameter called, instead of only years of experience that's impacting salary, the parameter could be the city where I work. Parameter could be let's say my education. Okay, the education. Parameter could be yes, tech stack. Yes, parameter could be the tech stack. Okay, okay, and so on. So basically, if you take a look at it, these are the dimensions of data. Just like years of experience, we have city, education, and the domain. Okay, so what we generally do is we prepare a table of such data. We, let's say, we prepare the table as, let's say, years of experience, and then we put city, then the education, then the domain, and then we have the target variable called salary. Salary is our target variable. So this is what we do in case of machine learning. So what we do is we prepare our data in this form, and then we feed it to algorithm. Okay, given the past data in which salary is given to us, and we basically give it to algorithm, and we let the algorithm learn from the past experience, and then when we provide only this data, then it is able to predict the salary. Okay, so then we uh, provide data for which we need predictions, for which we need salary. Okay, and it does the predictions. Okay, or let me just draw it in this way. So okay, so let me put it this way. This is better. Here we are feeding to the algorithm. And algorithm is learning from this. This is your model. Model means something that it learns about data. Okay. So the way here there was only one criteria called years of experience. And when we fit the line, this line is nothing but a model on which we'll be feeding more data, and it'll be giving us the prediction. Okay. So this is what is called machine learning.
So Sandeep,
Okay.
algorithm is the code we have to write. Algorithm. The code we have to write, or what is algorithm?
Yeah, these algorithms are standard algorithm. They could be linear regression, they could be SVM, they could be, are hundreds of algorithms. There could be neural network based algorithms. Okay, those are generally off the shelf available to us. Okay, those are generally available to us off the shelf. We just use them.
So do
Okay,
Scala and Java has the algorithm?
no, the programming language don't have algorithms, but the libraries like MLlib from Spark has those algorithms.
Okay.
Okay, great. So let's take a break for 10 minutes, and back by 12, 14 SGT. I am in Singapore. So this is Singapore time. Please post it in your time zone. Okay, so we talked briefly about two problems. One was the playing of Mario game. Second was with respect to prediction of the salary, right? So in this case, these, let me just give you some terminology. These are called features. These are called features. Okay, these are called features. Okay, and the records in this data, like the information about multiple people over multiple years, is called instances. This is called instances. Okay. So once we have created our data in this form, in two-dimensional format, instances, and for each instance we have the features, then we can make our algorithm learn the model, and then we can feed the data to, we can do the predictions using the model. So this is a general strategy with most of the algorithms. So we create our data in the form of a table or a data frame. We make the algorithm learn the data by using various optimizations, by using all kind of combinations, and then we prepare the model. And once we have done the model, here in this case, the salary will also be available. And once we have prepared the model, basically learning from the past experience, and then we will be able to feed this data and get the predictions. Okay, so that's the idea about machine learning. Okay, so all right.
So,
So yes,
Sandeep,
go
in
ahead.
MLlib, like model is prepared, algorithm and model are both are prepared in MLlib.
So algorithms are available as part of MLlib and scikit-learn. So these algorithms, these are called machine learning libraries. So the examples of machine learning libraries are, say, scikit-learn, TensorFlow, MLlib, and then there are, R has some machine learning libraries and so on. So you can basically use any of these. Okay. And then in Python, you have PyTorch. In Java, you have deep learning for J and so on. Okay, so that
So
way.
model we have to prepare after feeding the
We have,
data.
yeah, we have to feed this. We have to call algorithm on this data. So algorithm will generate the model.
Okay.
Okay.
Okay. And the model will generate the prediction.
Using model, we can do the prediction. Okay.
Okay.
So that's the strategy. So basically our data, the past experience, is fed to the algorithm. Algorithm generate the model, and on the once we have the model, then we can start fitting the we can start asking for prediction. Let's say we want to find out the answer for three years, whereas we don't know the salary. We feed that data, and then it'll give the prediction of the salary. Okay, so that's the general strategy in any machine learning. Okay,
So Sandeep, I have a question. So for data
this is
like this,
Rajan.
yes. So
Okay.
for the data that we are considering now, it is
Mm-hmm.
not necessarily a big data, right? Maybe a person's experience is probably what 60 or 40
Yes,
years.
that's correct.
Let's say that I want to use Spark for this,
Mm-hmm.
but I don't have this entire big data infrastructure.
Okay.
Is that still possible to use Spark in that context? I want to use all the machine learning libraries, but I
Right,
don't,
right.
my data is not necessarily big data that I have millions and millions of rows.
Okay, very good question. In that case, you will just use the scikit-learn.
I'm sorry, repeat it. What?
In that case, of course, you can use the Spark MLlib even in that case, but it won't require too much of resources. Even if, let's say, you have, say, 10,000 record instead of millions or billions of record, still you can do those predictions using Spark MLlib. But a more efficient could be either using scikit-learn or any other library. But you can definitely do it over, say, single machine using Spark MLlib itself.
Okay.
Okay.
So the
So,
Spark has got a mode like that we can use, like.
By default, you saw that, let's say, creating RDD or DataFrame. if the data is smaller, it basically would create only single partition, and therefore it will behave as if it's a local node itself.
Okay, thank you.
Okay, good question. So, and remember our master yarn, master local, those kind of modes, those are applicable here also. Okay, great, great. Now that was a brief introduction. I hope this made sense to everybody. No?
Sandeep, I have a question.
Yeah, go ahead.
There could be a case wherein you have a lot of features, but not all the features could make sense. So how do you decide which are the prime features?
Uh, Good question. Good question. And that's why I would want you to come to the machine learning course. Okay. So essentially, there could be hundreds of features, and we don't have that luxury of choice generally. We let the algorithm build the model, and most of these algorithms give us the prediction on the features itself, that which features are more relevant, which features are impacting the output.
Would you say that that part is a part of the pre-processing, or it's a part of machine learning as well?
So that's a part of machine learning, of course. That's a part of
Deciding
machine
the
learning.
deciding the prime features.
That's right. That's
All
right.
right. And another question I have. I have like around 1 million rows of CSV data.
Okay.
So what would be the best approach of dealing with it?
Best
I
approach
want to
will be, yeah, as of today, best approach will be Spark MLlib.
Spark MLlib.
Yes.
And if it's a single node cluster, will it help, or it has to be a multi-node
Uh,
cluster?
it can help because you will be using the GPUs. You
All
can,
right.
sorry, it'll help because if you'll be having, say, multi-core, so RDD will be having multiple partitions and will be executed parallelly using those multi-cores.
All right, because I tried to use pandas and it's too much. It takes like a lot of time to even load and then display.
Right.
So it's feeling. So Spark is the only way of going through it because I
That's
have
right.
like about 1 million rows of CSV data. So the data is structured,
Right.
but um,
Right.
the
Right.
computer is not able to support.
Right. 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 So when you here, if you create the data frame of Spark, that will be the best way to handle that kind of data. Because if you try to create Pandas data frame, Pandas is another library uh, in Python, which provides you a data frame which can be fed to the machine learning algorithm. If you create the Pandas algorithm, Pandas data frame, the chances of it overflowing everything is very high. Okay, because it's going to load everything into memory. In case of Spark, that is not true. Spark, in case of Spark, since the data going to be distributed under the hood, the data frame is going to be distributed under the hood, therefore it won't overflow anything. Okay. All right. So a question from Vinda is, both Hadoop and Spark have themselves machine learning library. Could you show us some examples how to use them? Sure, sure. So I'll not be going with Hadoop machine learning library. Hadoop machine learning library, there used to be something called Mahoth, but that has been phased out. And now that also has been ported to Spark. Okay, Mahoth has also been ported to Spark, and therefore it won't be much possible to do that. But if you want to take a look at the older version of say movie recommendation, you could take a look at Hadoop. All right, so now there was a blog post that we had posted called Mahoth. You could take a look at that one. Okay, in our blog.
Then, out of question, can Ambari manage Kafka?
Can Ambari manage Kafka? Yes.
Kafka topics and all it can manage.
No, I doubt if it can manage, because though what Ambari guys are doing is they are adding more and more views. So I'm not sure if they have added something called Ambari view into it. But I doubt if it is able to provide those topics and all, right,
Okay.
in the
But it
UI.
manages Kafka.
It
Ambari.
manages Kafka. Using it, you can do like reinstall, uninstall, enable, and so on all the nodes.
Okay.
Okay.
Yeah.
All right. Great set of questions. Moving ahead. So this was, I hope this diagram is clear to everyone. So I was trying to explain that when if you are trying to predict your salary based on years of experience, you will draw the data points, draw the all possible lines, figure out which line has the minimum error, and then that line will be your model. And using that model, then you can start predicting. How will you start predicting? Once you have drawn this line is, let's say, large enough. Okay, let's say line is till here, let's say till here. Then let's say you want to do prediction here. You will just basically draw one line from this till this point, right? And then, okay, so based on this model, we'll extend it till here. Okay, and then based on this point, so model is telling that for this year, this will be the salary, right? So we'll basically do a projection. So somewhere this will be your salary at this point. Okay, so that's a graph. Now, if this is the model is a little different, if the model is like this, right? If model is something like this, then your projection will start from here. Okay, so your salary is going to be this much. Okay, this is really bad. So your salary is going to be somewhere here. Okay. So basically, once the model is done, you can do all kinds of predictions and so on. So, all right. Next is there are many applications of machine learning. Some of them are recommending dates, friends, product to the end user. For example, Amazon's way of giving recommendations is the one that earns them the maximum amount of money. Then the applications could be classifying content into predefined groups. It could be identifying key topics in large collection of text and doing the computer vision, identifying what is the object and so on. And doing the natural language processing, you must have seen the Google I/O in which Sundar Pichai, the CEO of Google, they demonstrated that how the bot actually, how the computer, the machine learning based algorithm placed an order, booked a table as well as booked a haircut time slot. So those are a couple of examples of machine learning. Now, there are many types of machine learning: supervised, unsupervised. In supervised, the one that we showed just now, that was supervised machine learning, in which we had example input, example output, and we learned to map inputs to output. In unsupervised learning, we don't have any training data as such. We have the entire, the whole data. Here, we don't have something like labeled data. So third kind of machine learning is reinforcement learning, where you have direct dynamic environment and we perform a certain goal. Supervised learning is further classified into two buckets. One is called classification and other is called regression. In case we are trying to predict a numeric value, we call it regression. If we are trying to classify into one of the buckets, then it is called classifications. Unsupervised learning, there are types of unsupervised learning. One of them is clustering. Okay, so classification could be, example of classification could be, let's say, email spam filter. Check the email. If it is a spam, then mark it. Otherwise, don't mark it as spam. Or recognizing the digits, recognizing the handwritten digits. So putting a label from 0 to 9 on a digit is a classification task. Regression, the one that we took example just now, is called regression. So in linear regression, we draw all possible lines through. Linear regression is a kind of regression in which we try to fit straight line into the data. We draw all possible lines that go through the point such that it is closest to all of the data. Now, clustering, there could be many kind of clustering. One of them is k-means clustering, and other is hierarchical clustering. So based on what we do is we try to group the data such that we could say that there are 3 buckets in it, and or data is structured in this manner. Say, for example, given the species from all across the globe, or from the whole earth, given the details about species, creating a hierarchical tree or species tree is a form of machine learning. It's called hierarchical clustering. All right. There are many machine learning tools. If you have very small data, like a couple of records or tens of records, you can just use a whiteboard and draw the line by yourself manually. If you have kilobytes to lower megabytes, which means thousands of records, then you can use MATLAB, Octave, R for and the similar tools like scikit-learn and so on. But if your data grows beyond megabytes to lower gigabytes, then you have separate tools for analysis as well as visualization. For analysis, you use tools like NumPy, SciPy, and Weka. For visualization, you have tools like Flare, MCharts, Refill, and ProtoVis. If your data is going beyond gigabyte, terabyte, or petabyte, going into somewhere beyond few million records, right, into gigabytes, then you would require, you can only do analysis on that data. You can't really visualize that kind of data. You will have to convert it into smaller data in order to visualize it.
I have a question over here.
Yeah.
So visualizations, after you've done your processing, would you store your data into your local machine and then do some visualization using these tools like Tableau or
No,
Flare?
you can
Or
use
you can do it
Apache
on the fly?
Thrift. You can use Thrift service, Spark Thrift server.
Okay, but like visualization using Tableau is more powerful and more popular as compared to Thrift, right?
Correct. No, so what you can do is you can connect your Tableau to Spark Thrift server.
Okay.
Okay.
So Thrift acts as like a mediator between the two.
Thrift is a server.
Okay.
Thrift will behave like a database server. So
All
Thrift
right.
as in Spark Thrift server. Thrift is a general service,
Mhm.
and Spark Thrift server is a server-side representation of Spark SQL. So you can actually run select X, select Y on your data frame.
All right. Because visualizing using Tableau is more powerful.
Right,
All right. Thank you.
right. Okay, great. Moving ahead. So if your data is going into gigabyte, you will require MLlib or Spark R or GraphX or Mahat or Giraffe. GraphX is for graph processing. We'll talk about it in a while. Okay, so now this was a brief introduction of machine learning and the tools. So machine learning library or MLlib from Spark. The goal is to make practical machine learning scalable. That is the goal. Okay, and of course easy. It consists of common learning algorithms and utilities such as regression, classification, clustering, collaborative filtering, and dimensionality reduction. Lower level, and it gives you the primitives so that you could, if you want to tweak an algorithm, you can tweak that, or create your own algorithm, you can do that. So MLlib, the whole package had been broken down into 5 categories. First one is the algorithms. Algorithms are the ones that basically generate the model after we feed the data. There are common learning algorithms available, some for classification, regression, clustering, and collaborative filtering. Then we have tools for featureization. Sometimes you want to do, let's say you have got thousands and thousands of features and thousands of columns, and you want to reduce that. In those cases, you generally use dimensionality reduction. Okay. Similarly, we have transformation and other similar tools for handling these pre-processing steps. Also, when we are doing the machine learning algorithms, or when we are doing machine learning, always we end up doing many steps again and again and so on. So in those cases, it is easier to create the pipeline so that when we can run the whole pipeline in a single shot on certain data. Pipeline could have running of an algorithm, running of a feature extraction step, and so on. Then we have fourth package called persistence. Persistence provides a way to load and save model as well as data. Okay. The fifth part is utilities. Utilities are general foundational utilities such as linear algebra, statistics, data handling, etc. Okay. So in MLlib,
Another
yes,
quick question before we move forward. Can you go back to the previous slide? One more. One more, where we had the table. Yeah. Where does SAS fit into the picture?
SAS fits somewhere here.
KBs to MBs?
Yep.
All right. All right. Thank you.
Okay.
But the data has to be structured for SAS, or if it's semi-structured, it's fine.
I'm not sure much, but what I have heard or seen so far is that it is a structured data processing tool.
Oh, structured. So tables should be there.
Right.
All right. Thank you.
What do you understand by clustering and collaborative filtering?
Yeah, that's what I'm coming to. Now, the MLlib provides you the collaborative filtering. What is collaborative filtering? Collaborative filtering is recommendation systems. Okay. When you take a look at Netflix, you see the recommendation that movies you may like, or similarly, if you are going to Amazon.com, it'll show you that you may also like these products. People with your kind of profile like these products. So that is called collaborative filtering. And clustering is giving data, put it into similar buckets. So you define the measure of similarity that, okay, given this class, let's create 3 groups. Okay. And the similarity criteria could be the distance, and we basically, based on that, we could create multiple groups. Let's say we want to create 3 groups in this class such that their distances are they are closer to each other. So that is called clustering algorithm. All right. The let's get back to the collaborative filtering. So the collaborative filtering is essentially the term commonly used for recommendation systems. The techniques under collaborative filtering aim to fill in the missing entries in user item association matrix. You can think of this way, that you have each row represents user, and each column represents the feature. So or let's say there are 3 columns: user. First column is user ID, second column is item ID, third column is how much this user likes this item. So generally, most of these techniques under collaborative filtering help us fill the missing entries in this, meaning given an item, predict which users will like it. Given a user, predict which all items the user will like it. Okay, that kind of suggestions are generated by collaborative filtering. It supports model-based collaborative filtering. The MLlib supports model-based collaborative filtering. Users and products are described by a small set of latent factors that can be used to predict missing entries. All right, you will see this part later. MLlib uses ALS algorithm to learn these latent factors. Okay, so product users and product are described by a small set of latent factors, as in each user is represented as internally some kind of numbers. Okay, so let's take a look. Let's try to do the movie lens recommendations. Okay, let's try to do movie recommendation. And the data that we have is in /data/ml dash 1 million. Okay, and right, we already have this data here. So let's open say CloudxLab. Where was it? I'll say my lab. I'm going to open Hue. I'm going to open Hue. In Hue, there is something called file browser. Okay. In the file browser, okay, let's go to data. And then ML1M. Okay, you'll have to clear this text box. Okay, so this is the data that we are talking about. So here we have multiple folders. One is we have user.dat, and then the ratings.csv or ratings.dat. This file describes us the users. The user ID 1 is female, the age is 1, and there is some more information here. And I think the fourth column represents the experience or something like that. Okay, so README will give you an overview of the data. All right. So here, so gender is male, female, then age, then occupation. The next one is occupation. All right. So we have the user information, and then we have, say, ratings.dat. Ratings.dat means this user 1 likes this movie 1193 this much. Okay, and they have rated this movie at this time. This is the timestamp. This is the user. First column is the user. Columns are separated by double colon. And second one is the item, that is movie. The third one is the ratings out of 5. And fourth one is the timestamp. That is our input data. Simple. All right. Now let's try to predict the movies for various users. Okay, using Spark. So this is our data, and based on this, we will try to do the predictions. Okay, so here let's walk through this code before we jump into it. So first of all, we are importing this algorithm. So this is the recommendation algorithm. Okay, let's launch the Spark 2. I'm going to launch the Spark 2, and all right, so I'm going to launch Spark 2. Bin Spark shell. Okay. So let me just walk you through in the meantime. First of all, we're going to import this algorithm. It's called ALS. And ALS, as we talked earlier, ALS means, okay, alternating, what was that? Alternating least squares. Okay, alternating least squares. All right, I'm going to, yeah. This is the URL that will be easier for you to copy. Okay. All right. Great. So let's start copying from one line at a time. So first of all, we are importing the algorithm. This is clear, right? Second is we are creating a class called ratings. This is the normal class, you see. Okay. What does it have? If we are saying where r equals ratings and we are saying 1, 1, 1.0 and 1, right? So it says it requires float while we have specified only the decimal. So we'll just say F. Great. So we are able to create the object of this ratings class. It has how many variables? It has user ID, movie ID, and ratings. So it's just a usual class having 4 parameters. Now we're defining this function called parse ratings. Okay, this parse rating, what is it doing? Let's walk through it. So parse rating, so it's basically a project. So all of you should do it with me, as well as you should do it at your own time. So here, what we are doing is we are saying calling parse ratings. This function takes string as the argument, and then in this string, it first splits it by colon. That becomes an array of fields and checks if the fields have a size of 4, and then it returns the ratings object by parsing each of the field values. So zeroth field value, it converts it to integer, second one to int, third one to float, and last one to long. Okay, let's take a look if it is working on each line. So this parse rating, the objective is this file that we talked about here. This file we want to process using parse ratings. Parse rating, this line we want to process using this. So you can see it has created the object of ratings using parse ratings. Okay. So rating represents which user has rated which movie how much. Okay. Let's say I'm rating some movie as 5. That means I really loved it. So this user 1 has rated this movie called 1193 as this one. So there is movies and users. If you want to know about users and movies, then you can take a look at that. And then we have the timestamp. All right. So basically, each row we have converted into one rating object. Next is we are loading the actual data. Now we are saying Spark context.text file, and we are passing the location of the file. So you can see raw. How does raw look like? Let's take a look at, say, 2 records. So what will raw have? Each line of this file will become 1 record of this RDD. Okay, so you can see it has given us 1 and 2 records. Okay, because we said raw dot take 2. All right. Next step is once we have loaded the text file, we will say raw dot map, and we call the function parse rating on every line of the raw. Okay, so our parse rating will be called on this, and so on for every record from the RDD. So this is going to call our function parse ratings on every record, and then it's going to convert the entire parse data into data frame. That's ratings. Okay, so ratings is now a data frame. Remember how we converted the RDD by using the two data frame? This is that same mechanism. So we are able to create the data frame from our raw data using this technique. Okay, now let's in every machine learning program, what we generally do is we break down the data into test and training, and then we train on one part and test the model against the second part. Okay, this is to make sure that our algorithm is working really well. Okay, so here we have broken this data into two parts, training and test. Okay, so training is 80% and test is 20%. Okay, so there is a method called random split provided by Spark on the data frame, which basically splits the data frame. It splits the data frame of rows of the data frame into two buckets based on what you pass here. All right, now we have training and test data. We are going to train our algorithm on training, and we can later on test it on the test. Okay, so here we go. So what we are saying is we are instantiating the algorithm. This is the algorithm provided by the library. Then we are giving it some hyperparameters like maximum iterations and regression parameters. And then we are mapping the various fields required by the algorithm to the columns of our data frame. So we are telling the algorithm that user column is user ID from our data frame, and item column is movie ID from our data frame, and the ratings column is the rating column from our data frame. That's what we are telling it. So we are
The question.
initializing the ALS. Yeah, go ahead.
Oh yeah, so I was asking you about how would you decide the prime features, correct? So
Right.
in this case, you've decided three, like user ID, movie ID, and ratings as your prime features, and you dropped the timestamp, right?
Yes, because our algorithm doesn't need it.
All right. And what does five, like set max iteration that's as five? What does that mean?
These are called hyperparameters. These are the knobs for your algorithm. So what you generally do is you try different parameters. You search
Mm-hmm.
various kind of hyperparameters. These are called hyperparameters. We use the various kinds of grid search, random search, and so on to figure out which permutation of these parameters is giving us the best result. So these are the trade-offs. So if you increase the iterations, that means it's going to take a long time, but it's going to give you better result. If you say max iteration is equal to 5, it's going to finish in a couple of minutes, a couple of seconds, and
Mm-hmm.
but the accuracy may not be that great. So
Correct.
similarly, every algorithm provides these knobs. We call them hyperparameters. We basically have to tweak these knobs in order to trade off trade off the time versus the accuracy of the results.
Correct. So
Okay,
this is like a trial and error thing that you have to change.
that's
You have to
right.
change to find the quality of your results.
That's right.
Whatever gives you the maximum is the right setting.
Correct. Correct.
All right. Thank you.
Okay. So this algorithm, we are instantiating this algorithm, setting the some parameter. These are the parameters that we have set. Then we are also setting some more things that are needed by the algorithm. Algorithm wants us to specify which column from your data frame contains the actual user. then which column in your data frame contains the product, and which column contains the ratings. So those are the things that we are specifying using this. Okay. Now, once we have
One quick
created
question.
the algorithm, then we can fit the data, and then that will generate the model. So you can see this is our algorithm ALS. We are fitting the data. You remember our diagram? I'll just show you. Just give me a second. Here, you remember? Here, this was our algorithm. We are feeding the data to it. It is generating the model. Okay, generating the model. So after fitting, it generates the model, and then we do the prediction. Go ahead now.
Oh, yeah, thank you. What I was saying is like rerunning the code over and over again wouldn't result in overfitting.
Good question. So basically, this is something I would love to explain in detail. Uh, it depends. It depends. So you keep on running it until the point it starts overfitting. When you start overfitting, that means it is trying to memorize everything instead of doing the prediction. And that would be bad in case the input data that is coming to it, it has not seen. Okay. So those who are not aware of what is overfitting, let me explain. Imagine that there is a kid who goes to the school and memorizes the entire maths book, and when he sees the questions in the paper, he can't recall because those questions in the exam were different from what are in the textbook. Therefore he fails badly. So why he failed? Because he overfitted. He memorized the mathematical sums instead of learning the technique. So he did not learn, he memorized. Similarly, there could be another kid who just studied the first chapter of maths book, that is like addition, and did not study multiplication or subtraction. And then he's trying to solve all the problems with addition. He will also fail, his marks will also be bad. So this is called underfitting. Underfitting where you learn least, overfitting when you try to memorize everything. Okay, so when we are trying to force or impose on an algorithm that do more, increase number of iteration, and create more and more graphs and so on, that it will end up memorizing. So this graph that you see here in this diagram here, the algorithm might end up doing things like creating the graph like this. Okay, this is overfitting. Okay, this is overfitting. So yes, so that's the fine balance you have to keep intact. That's why we are breaking the data into training and test, so that it does not, every time we do create it, we will test our results on the test. In case it's giving the bad result, that means our algorithm is trying to memorize everything. Okay, we will train our algorithm on this set, and then whatever is the result, we will test it on test, and based on that we will learn whether our algorithm is overfitting or not. Okay, so we'll start from underfitting, one iteration, two iteration, three iteration, four iteration, five iteration, and so on, and we'll keep on observing the accuracy. If the accuracy will improve, and then accuracy will start dropping. So accuracy will increase as we are going from underfitting to the proper learning. And if when we start going to the overfitting, then the accuracy will drop. All right,
Another quick question.
did it
I
make
was,
sense to you?
yeah, totally.
Okay,
Another
all
quick
right.
question I have is like in the commercial spaces, do they stick to the algorithm like the way it is, or do they modify the algorithm as well? What I mean to say is you simply import the library and use it the way it is by just playing with the parameters, or you play with, like you make and tweak the algorithm by any chance.
What?
So like if you have supposing a classification problem,
Okay.
so would they simply import the library and then use the algorithm the way it is, or would they tweak the algorithm?
No, you have to tweak. So it all depends on what problem are you trying to solve. Okay. Sometimes you might have to tweak it. Sometimes you might have to write your own custom algorithm. Sometimes you just have to remodel your data and so on. Okay. My experience has been that it is important to have the control over the algorithm that you're going to use. Even a very simple recommendation system that I wrote for in Mobi, where we had 200 terabyte data, last moment we realized that we were using so much of RAM, and that moment of time we had to tweak more things so that we could get it done really efficiently. Okay, so we need to have the control, we need to have the understanding of what we're doing.
All right, so
When
algorithm
the
would have to be
Yeah,
good.
when we are just building POCs, the proof of concepts, then everything looks easy and beautiful. But when it comes to actually solving a problem which we have not seen, then things are a little bit more harder. Okay,
Correct.
so it's like the second kid who basically memorized everything. The same thing happens for the machine learning scientists also, or machine learning engineers also. All right.
Thank you.
Great. So once we are done with the training, it'll generate this model, and this model can be saved for later use so that it can be used in the production, in on your web server, and so on. So here, once you have saved the model, you can load the model and run it. Okay. Here, just we are saving it for keeping it there. Okay. So let me just give it a name. Proper name was the date today is 13/05/2018. All right. You can see that when we are trying to save, it is doing the recomputation again. All right. It says that allocated memory is this much. Never mind. So I think it has saved it. Now we can do the predictions using this model now. Okay. The predictions, you can take a look. A question from David is, I guess chat is broken. I did not get that, David. Would love if you could just explain more. Question from Bintao is that where can I find the function method in this? You can just take a look at the MLlib algorithm library. Okay. I see. I'll just give you a link to the documentation. You could go through that. All right. Now next is we're going to save this result somewhere. So here I'm saving it in the, what's the date today? 13 May. All right. So it's basically running entire thing and trying to save the prediction in the file. All right. So this is how you can generate the movie recommendations. Take a look at a folder in the files here. Let's just go to the home directory here. Okay, so here, if I sort my files by the date, I shall be able to see the, is that the one? ML dash predictions. I did it in a different folder. Ouch. Actually, I'm running it as Sandeep at this one. So I might have to log in there in order to see the results. All right. So Hadoop fs/ls and fs space dash ls. So that one would show us all the folders. In here, you will see ML predictions. And is that a directory? This is a directory. So note to myself that every time when we save, it's a folder, not a file. Okay, so it has done so many predictions, so many files are there. We can concatenate it and see the results. Now, the same one, whatever we have done the training, it can be used for our own use cases. All right. So what we just did was we did the movie recommendation, and you can take a look at it. So what it would have done is for all the users, which movie should be recommended, it has given those recommendations. And you should take a look at that. In case you really want to take a look at it, I'll just show you. I will just take a look at maybe one of the files. Let's say this one. Okay, so I'm going to show you this part. Am I making a mistake here? Uh-oh. Okay, I'm doing that twice. All right, let's take a look. I hope the records are not too much. So it has given the recommendation that for this user, this movie ID, okay, is recommended this much. Oh, this was original, sorry. This was original, okay? And it is suggesting that for this user, this movie ID is recommended this much. Actual was 5, now it is giving 4. Okay, actual was 1, here it's giving say 3.9. So the results are not very great. Maybe when we run it again, we shall be able to see that. Okay, when we run with more number of iterations, we shall be able to see that actual and the predicted values should be similar. Also, we can compute the accuracy of our algorithm by comparing the actual and the predicted. Okay, so that's about the recommendation. An assignment for all of you: find the maximum user ID, create the next user ID representing yourself, put your ratings of various movies into the data frame, generate your movie recommendations, and once you are done, write down the steps in the Google Doc and share with Reachers at CloudxLab. Okay, that's an assignment based on today's discussion. Okay, a question from Mohammed is how to get a confusion matrix. So you can take a look at the API in detail of MLlib and you will get the idea. Okay, so I'm going to just walk you through that. All right. So this is the one that you could use in order to generate really good movie recommendation for yourself, but you will have to put your own ratings for various movies. This is something you have to do. Okay, once you have done it, then you can ask Spark MLlib to suggest a movie for you. Okay, take a look at the APIs. Take a look at the APIs of the specifically the ALS API or the model API, and you'll get the idea. Great. So this is something, an assignment for all of you, and right. So I'm just copying this and giving it to all of you so that you can work on this. Okay. Consider it as one of the projects. All right. Okay. So other than the out of the box recommender algorithms, it also Spark MLlib also provides the local vector, label point, the matrices, the local metrics, distributed metrics, and so on. And it also provides us the pipeline. It provides the various classes like transformer, estimator, pipeline, parameter, and data frames. So here, like if we are trying to do a complex text processing, so you might be taking a raw data, converts into words, convert each word into vectors, and then do some kind of regression or some kind of algorithm fitting. So there could be many steps. So entire thing can be run in a single shot. Okay. So that's basically the idea of pipelines. And the Spark MLlib also provides the basic statistics. Take a look at various statistical functions here. Various statistical function here. Okay. So this is a very good documentation place. You must take a look at it. Okay. This is the place where you have basic statistics, pipelining, extracting, transforming, and selecting features. Then the what do you call supervised learning, classification, regression, clustering techniques. Then recommendation engine. Then these are frequent pattern matching, as in if you want to suggest that people usually buy these things together and so on, you can use frequent pattern matching and model selection and tuning. So take a look at these these functions. So and so this one is a very detailed one. So take a look at if you are really interested. So just a hint for all of those who want to just quickly understand this. So anybody who has used scikit-learn, SKLEARN, learn, scikit-learn, this API of Spark has been built on the same principle as scikit-learn. So if you're coming from scikit-learn kind of background, it'll be really easy for you. Okay. All right. So that is about MLlib. Those who want to get more understanding on machine learning, come over to my session tomorrow morning. Tomorrow morning, that'll be on 7 a.m. IST. It's a machine learning session, and you can sign up for that session if you have not already done it in the event section. Okay, so here, free session on machine learning, you can register here. Okay, you can register here in case you want to. This is a free session for all, so come over. I'll go into, there will be more basic session. All right. All right, did you get the link? I just copy pasted. All right, great. Feel free to invite your friends. It's going to be around 7 hours from now. Great. So that was the basic idea about this. Go through these documentation, which I have put in here in case you want to go into details. The course on machine learning itself is a 6 months course, truly speaking. So it'll be hard to cover entire thing. Okay. So I cover most of these ideas in my usual deep learning course. That's going to be start from tomorrow. All right, so moving on to say GraphX. All right. So far, what we learned was using MLlib, we can process the using MLlib, we can process the we can process the we can do the predictions, we can do the machine learning related tasks. But there are many tasks which are okay. Let me just check the questions if you have questions. All right. Now, moving ahead. So one of the very important library from Spark is the GraphX. It's not a database, it is a library, meaning a bunch of algorithms which you can use to process the complex structures. So for table oriented processing, we use the for table oriented processing, we use the DataFrame. For row oriented or record oriented processing, we use RDD, right? And for graph processing, we use GraphX. Okay. For graph processing, we use GraphX. What is a graph? Graph is the most common data structure which occurs when we try to solve any problem. Like when I describe something to you, it is generally in the form of graph. So graph generally represents having nodes and the edges. So in this case, we have 4 nodes, 2, 5, 3, 7, and there are 4 edges. So from 2 to 5, 5 to 3, 3 to 7, and 7 to and 5 to 7. So this is the graph. So this kind of graph basically has names for edges also, as well as name for the nodes also. Okay. So generally, this is the visual form of the graph, but we generally represent graph as 2 tables. One table representing vertices, second table representing edges. So this is the way we usually represent a graph. Okay. There are many examples of graph computation. For example, finding common friends, finding the page rank, and many more. All right. So for example, we want to find the common friends. So let's imagine that there is a graph in which there are users connected to each other and we want to find out common friends. This is what we call common friends. Then finding PageRank. This is the algorithm that made Google Google. This is the algorithm that brought Google out of nowhere into the #1 company of the world. This simple algorithm. This simple algorithm called Google PageRank. Okay, so all right. So let me describe the PageRank. Before that, there is a question from Mintauli. Will you offer free Python course for machine learning again this time? No. This time, because we are just offering the recordings of the previous session in the course. Okay. And yeah, so this is a very important algorithm in the history of computation, which made the one of the very successful company in the space of search engine. And how does it work? So let's say there is a web page which is linking to another. So this one, the linking is viewed as voting. So the more people are linking to you, that you will be more important than them. And if more important people are linking to you, then that will be even far more important. Okay, so your rank depends on how many people are linking to you, as well as who are those people who are linking to you. Okay, so that's the page rank. So GraphX unifies the graph computation. It provides ETL, exploratory analysis, and views the same data as graph as well as the data frame. So it transforms and joins graph with RDD very efficiently, extends Spark RDD by introducing a new graph abstraction. All right. So there are many algorithms under the umbrella of GraphX, such as Pagerank, connected components, triangle counting, and label propagation, SVD++, and strongly connected components. All right. It provides very fundamental set of operations. Also, not only the algorithms, it provides these fundamental operations like finding whether a graph is a subgraph of a bigger graph, joining the matrices of two graphs into one, then aggregating all the messages from the whole graph, and so on. So you can take a look at the GraphX API. Now let's talk a bit about PageRank. Let's say we know who is following who. Let's say Justin Bieber is following Barack Obama, and Barack Obama is following Lady Gaga, and Lady Gaga is following Barack Obama, and so on. And in your opinion, who is the most important of all? Anybody? Out of these people who are following each other on Twitter, who is the most important? Let's just talk about this one first graph. Out of Barack Obama, Lady Gaga, and Justin Bieber, who is the most important person? Or who is the least? Let's just start with the least. Who is least out of these three people? As I said, the more people follow you, the more important are you. So out of these three people, Barack Obama, Lady Gaga, and Justin Bieber, who is more important? So least is Justin Bieber, okay. Okay. And out of Barack Obama and Lady Gaga, who is more important? If this is least, so he is out of competition. So now out of these, who is more important? One and two are equal. So who is being followed more? Barack Obama or Lady Gaga? Correct. So basically, he is more important. Now, out of this, again, we can do the similar kind of work and figure out who are important. But when this graph goes bigger, say millions of users, and each of them connecting to each other, that becomes million into million. And it becomes impossible to use the usual algorithms. And this is where the GraphX comes into play. Okay, so here we are going to take a look at this data. All right. So who is following who? We have file containing that. Okay. So we have, I'll just exit this or let it be. Okay. So you could yourself take a look. So imagine that we have this graph. 2 is following 1, 4 is following 1, 1 is following 2, 6 is following 3, 7 is following 3, 7 is following 6, and 6 is following 7, and 3 is also following 7. So this is the graph of who is following who. And we have to find out who is most important out of these people. Okay. So let's take a look at if we can find out. Okay, so this is something that we have already done. Now we are importing the graph loader. Okay. Do you want to try it with me? Okay, please try. So what we're going to do is we are going to compute the page rank, going to compute the rank of each other based on who is following who. All right. These are the list of followers that we have already seen. These are the list of followers who have already seen. And Okay. All right, let's just import the graph loader. Okay. And then we load using the graph loader. We are loading the edge list using the follower.txt. From this file, we are loading the graph. Okay. Once we are done with that, we are just computing the page rank by using this. And take a look at it. So it has done, it is doing the computation. It is doing the computation for us. Okay, let it do the computation. All right, let's take a look at the results. So you can see that here 4 has got 0.15 as the rank, while 6 has got 0.7 something. Okay, and 2 has got a huge rank called 1.39, and 1 has got 1.45. And who is 1? Let's take a look. Let's take a look at 1. So 1 is Barack Obama. The rank, the page rank is 1.458, right? Then second is okay. Second and seventh. Second one is Lady Gaga, and then 7 is 1.29. 7 is 1.29. I see. This one is no. Oh, there are actually more. 7 is being voted by 6 and 7. 6 and 3. That is not listed here. Or maybe this is the one. All right. Okay. So basically, this is the use of GraphX. GraphX can do this kind of graph processing really easily. Okay. And here further in this part, we are trying to put names on the people using the users.txt. Users.txt contains what? It contains the information about each ID. It has the name of each user. Okay. So that's what we are doing in the rest remaining part, printing the name along with the user. Okay. That's what we are doing. We are joining the two user based on the user ID and rank. So you can see here Justin Bieber has got 0.15 as rank, and here Barack Obama has got 1.45. Lady Gaga has got 1.39 as the rank. All right. So try doing that. Create. Take a look at your friends and see who is following who, just based on the Twitter graph, and then try to feed that to PageRank and see who is most important amongst your friends. Okay, try doing that, and that you can take it as an exercise. Just first of all, list down all your friends or all your followers on Twitter, people who you follow as well as who are following you. Just list it down as a graph, and then out of their friends, just see if you could come up with the list of IDs, or see the Twitter can give you the entire dump. Okay, so take that and prepare the graph and see if PageRank is giving you something reasonable. All right, so that could be a quick assignment, and try doing that in your as assignment. So that was the GraphX. Okay. All right. So that's pretty much about the GraphX. All right. So and all right, the project for all of you is one is with respect to the MLlib that I have given. Okay, that is one of the projects. that try generating the movie recommendation for yourself and document the approach and share the project report in Google Docs. Okay, so that I can give you the feedback on your project. All right. Similarly, here also that so there is first one is okay. So the first one is this and this. Okay, these are the two projects. And third one I want you to complete is okay, this one blog. Okay, where is that real time? All right, so is there a dashboard or something? Yeah, here. This is the third one that I want you to complete. Okay, so these are the three projects. Okay, this is Spark project, this one. Okay, please note it. Okay, this is one project. This is second project. And the third one was with respect to the machine learning with Spark R. And okay, so third one was the machine learning example, the one that I have given you. Okay, so that is the project. All right, so try completing these three projects. It will be very useful. And when you are done with, say, this project, at least one of these projects, if you're done with, you can take at least one is required for getting the project certificate, as in the course certificate. Okay, so please try to complete that. It'll be quite useful to you. Okay, so these are the three projects that I want you to work on. One is the movie recommendation for yourself. Then second is building a real-time analytics dashboard. Third one is the Spark log parsing. So I would strongly recommend that you try doing all three. Okay. Okay. So just submit the first one. Okay. And in case you are getting delayed, please let us know individually. We will try to do that separately. Also, you can share the lab link with your friends or on your timeline so that you can keep getting auto extension to the lab. Okay, on every if your friend is just signing up, you will get the 15 days extension automatically. Okay, so that way you can keep on getting more and more labs. Or in case in future you want to retain it, you can just take the subscription. That could be easy. And regarding the more dates, if you want more than 15 days, please reach out and let us know upfront. Okay. So, all right.
Sandeep, my lab has been expired. Can you see?
Yes, just send me an email because I think for some users it has been expired, and I need to see why did that happen. Because as per my team's response, they said that everybody's end date was set to 30 May. Okay, so could you just send an email to reach us at CloudxLab?
Yeah, I
I'll
sent
take.
it today.
Okay, I'd love to resolve this. All right, so you can have in order to submit the project, you can have say 30th May, the last date. Okay, 30th May is last date to submit at least one project. Okay, all right. So these are the three projects I want you to complete, and the more the better, because that gives us the confidence that you are really interested in taking up the work. All right. So thank you, everyone. It was a great course, a great batch. I got great set of feedback, got great learning. And all right. So in case you want yourself to unmute, just raise your hand. I'll unmute. And okay, so all right. So it was wonderful to have such an audience in the class. You have gone through the entire grill of Spark. Some of you have also gone through the some of you have also gone through the entire Hadoop. So feel free to reach out to me at reach us at CloudxLab. Why I always intend to say reach us? Because my whole team looks at that inbox, not alone me, and that's very important. All right. So I look forward to see you on the discussion forum. I look forward to see you in the events, in free events, and okay. So Alvin, Alok, if you or any of you, if you want to unmute yourself, feel free. All right. Also feel free to write our Quora reviews. Quora reviews. Though we have a lot of Quora reviews on no big data on for this course. Okay. So CloudxLab Quora reviews. All right, I think this is the course. The same thing is actually redirecting to both the places. All right. I'll send you the link if you want to review. Okay. So this one has 3 reviews, though our no big data has around 20 reviews. So feel free to write a review here and let us know. All right. There are a few things, and so yes. Thank you, Rajan, for kind words. And all right, feel free to reach out, Rajan, at reaches at CloudxLab. That is the best way to do. And yes, I would love to help you in the project. Just feel free to drop us an email. We can schedule a one-on-one. Thank you, Alok. I'm happy that you found the great learning experience. Thank you, Subbu. And all right, stay connected. The world is really small. If you are sending me a LinkedIn request, please put down a couple of words that you are from the class. Of course, I remember you. But since there are just too many requests there, so I tend to overlook and don't add people there. So please just mention that you are from the class. It'll be great. All right. So great. I thoroughly enjoyed your questions. I look forward to see you, and feel free to join our sessions in morning or anything, and stay connected because our learners are our most important uh, priority in the company. That is something which we have set up, and we make sure that we stay tuned to that one, just like Amazon is obsessed with the end user. So similarly, we also have the similar principles. Great. Thank you, everyone. I look forward to see you. I look forward to stay connected with all of you. Okay. Bye-bye, everyone. Have a good day. Stay connected and stay connected on the forum. Forum is quite active. A lot of people keep asking questions there. And if you have any doubt, any questions for future or anything, just feel free to reach out. Okay, that's the most important part in the career, to reach out. All right. Bye, David. Yes, Rajan, there would be ML discount. There will be a discount on ML course. Just reach us at CloudxLab. I had given them the guidelines on giving discounts to our students, so probably they'll be following that one. Okay. All right. Thank you. Thank you, Alvin, Alok, Bharti Raja, Bintao, David, Grishma, Hitendra. Feel free to unmute in case you want to say something. And thank you, Jay, Muhammad, Rajan, Raju, Ravi, Robin, Sachin, Shravanti, and Subbu. I thoroughly enjoyed your questions. All right. Great. Have a great career ahead. Would love to help you in the career. If you have any question, please feel free to come over. Feel free to drop an email, or if you have a technical question that you think that other people can also answer, put it on the forum. All right, great. So in case you want to unmute, feel free to unmute and say, else we can call it a day.
Thank you so much for the class, Sandeep. It was amazing to be a part of it. And you cleared most of the doubts. Thank you so much. I
Thank you,
learned a lot
Mohammed.
from this class.
Thank you, Mohammed. I really enjoyed your questions. Actually,
Thank you.
most of the questions all of you have asked is actually wonderful.
Right. Thank you so much for the consistent support. I hope that I can finish the project and get the certificate.
You will get, yeah.
All right. Thank you.
Okay, thank you. All right. If anybody else has to say anything, feel free to unmute. I'll be here for some time. Else you can say goodbye and have a great day.
Hey, Sandeep,
Hi, Robin. Yeah,
I really appreciate all the knowledge which you shared to us. Thank you very much, sir.
I
I learned
enjoyed
a
your
lot.
questions.
Thank you. Thank you.
Stay connected. Yeah, thank you.
Yes, sir. Cheers.
Thank you. Bye.
Bye.
All right. Great. Have a good day. All right then. Should we hang up, or is anybody else wanting to unmute and say?
Thanks, Sandeep. This is Sachin here. Thanks for all your support and answers. For you have answered all my questions and queries.
Great, great. All right, Sachin, I totally liked your questions. I look forward to see you in the sessions. I look forward to see you maybe connected to the LinkedIn or stay connected on the forum. There are a lot of good questions there. Try answering those questions. All
Sure.
right.
Thanks. Thanks,
Okay,
Sandeep.
great, wonderful.
Hi, Sandeep.
Hey, Alok. Yeah.
Hi, hi. Thank you very much. I had a great experience of learning, and all the things are very good.
All
So
right.
just
Great.
I want one suggestion, like if
Mm-hmm.
what means whatever we have learned, that is a great. And
Mm-hmm.
if we want to get the mastering kind of expert on that Spark like that, what can you suggestion can give us? What is the path we should follow and ahead of this after this
Okay.
session?
Okay. Okay. So my suggestion would be uh, try say solving some of the hard problems on bigger data. All right. How will you do that? Basically, uh, so there are these open source data sources. Try those data sources and see if you could process some of the data in order to see some insights. Okay, say for example, there is this blockchain, the data of entire blockchain. You could download that one and try this. Also, the next thing I would suggest is say go through the documentation of the Spark. That is probably the best amongst all the books and everything, because books and everything are getting um, become really old by the time it prints out, because Spark had changed like 10 times in like 3 years, and therefore the books have become really useless. Most of the books which I suggested to IBM when they were my students, so they, all of that has become, by the time the book came to them, it was already old. So great. All right. So I would
Yeah.
suggest that take a look at their documentation. Their documentation is really good. Also, if you are planning for machine learning, come over to the machine learning course. That's probably one of the best course that we have worked on. It is the most detailed course. All right.
Actually, first I want to get more comfort into this Spark and Hadoop.
Okay.
After then, I will look into that machine learning.
Great. 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 So try solving the three projects. I think by the time you will finish the three projects, you will be very comfortable.
Okay, thank you, Sandeep.
Okay. Thank you.
Bye.
Bye. All right. Anybody else who wants to say something, or should we call it a day?
Hey Sandeep, this is Jayesh.
Hi,
Thanks
Jay.
for the class. Hi.
Okay.
The class was really interesting. I learned a
Okay.
lot, and I guess I'll probably be using all the things you have in terms of the material
Okay.
for a lot of the learning, and hopefully some projects that we do. Thank you so much.
Wonderful. Great. Great, Jay. I totally enjoyed your questions. I look forward to stay connected.
Right, thanks. And also, just a quick thing, one of the things that we had done with the Unix, where we did the sorting and the unique for the, mapping, reducing part,
Mm-hmm. Mm-hmm.
I was actually able to use it on one of my current ongoing projects, So that
Oh,
was really
nice.
helpful. Thank you.
Oh, nice. Oh, nice. So that's something that I try to achieve. But yeah. So what my general objective is that you should learn things subconsciously instead of memorizing thing, so that when the situation arises, you are able to apply that. That's actually biggest achievement I would say that I have in your case.
No, definitely it helped. Thank you so much.
Yeah, thank you. Okay. All right. So great. Anybody else, or should we call it a day? All right. So great, great. I think others are not available probably. So thank you, everyone. I look forward to stay connected. and feel free to reach out to us at any time, either on the forum or at reaches at CloudxLab. All right. Bye-bye. Have a good day. Thank you.